Welcome to a series of lectures on mathematical economics that I developed over a period of time from about 2018 to 2021. These lectures were given to students taking a course in static optimization and a course in dynamic optimization. The book that was used in the course was entitled Mathematics for Economics by Michael Hoy and four of his colleagues at Guelph University. Although I deviated from that book in many cases looking at the kind of work I've done in research type of work, and also I've used the book by Dixit called Optimization in Economic Theory, which was written in 1990, and it's a small little book. So what I want to do here is just introduce you to the set of lectures and what they contain as a broad brush rather than anything beyond that. I begin by looking at lectures in static optimization, beginning with calculus. The first lecture will look at calculus meant for students who have little or no exposure to calculus and only looks at differentiation. We continue with differentiation through the mechanisms of how you optimize a single variable function and then function with more than one variable. I then look at matrices through a number of lectures. Then I begin with optimization in the context of economic theory. I also continue with that into the production and into welfare economics. The second series of lectures deals with dynamic optimization, beginning with integration for students who have not had any exposure to integration. I then look at dynamic equations and how you would solve difference and differential equations, how a solution might involve phase plane diagrams, and finally how you solve a system of difference or system of differential equations. I then turn my attention to optimal control theory and how you solve problems that are dynamic but involve optimal control. This then leads into dynamic programming and stochastic dynamic programming, which are a bit different in terms of how you control things, but I show that they are the same as optimal control. It's just that you might solve the problem somewhat differently, and with dynamic programming, solutions are easier to obtain. And finally, I end with an introduction to linear programming and RStudio.